Okay, so first today I want to review a little bit of yesterday. Yesterday you learned how to do long division, first with numbers, which some of you knew. Then we moved on to polynomial long division. All right, so right now I just want you on a blank notability doc, and I want you to give this one a try. If I was going to put 7 into 2013, nope, 2013. It won't work out, maybe. Well, maybe I know the other one had a chance of working. This one probably won't work, as in you'll have a remainder. All right, I'm going to pause for a second while you give that one a try. All right, so today we have this answer for our long division, and then I'm going to have you try a polynomial one in just a second. Okay, so here is a polynomial long division for you to try. The question would be, is x plus 2 a factor of this? X to the third plus 5x squared plus 7x plus 2. Really, our goal here is to try to factor this. And I don't think you could factor this the old-fashioned way, but you can with long division. You can't do it with breaking into chunks, I don't think. Yeah, I'm pretty sure that would not work by factor by grouping. So I'm going to pause for a second while you try to work this one out. Actually, I'm going to give you the first step because a lot of people just get stuck on the very first step. You put a number right here that when you multiply it by x will make this work. And I said the answer is usually you put an x or an x squared or a 2x, something with an x there. Almost never we just have a number. So let's try an x and see what happens. X times x is x squared. Well, that didn't match up with the first term, so I can't use it. X squared. Raise your hand if you started with an x squared. Good, then you're doing it right. That makes x cubed, and then x squared times the 2 makes it plus 2x squared. That's how you start. I'm going to pause for a second while you finish. All right, so let's see how you did. First step, change this to minus and minus, and then you'd have these two canceling, and then you'd have 3x squared. Then I bring down the 7x. And then I say, what can I put here so that when I multiply it by x, I will get 3x squared. And that would be a 3x. I am recording. Plus 3x. I wish this thing would like blink or something when it was recording. So, but it is. All right, so I'm going plus 3x, and then 3x times the x makes 3x squared. And then 3x times the 2 makes plus 6x. And then I put an opposite and opposite. And then I go like this, and then this becomes x. And then I bring down the plus 2. And then, ooh, that's an easy one. What do I need to put here? A 1. 1 times x plus 2 will make x plus 2. There we go. So final answer is, this factors into x plus 2 and x squared plus 3x plus 1. Raise your hand if you had that one right. That's the vast majority of you. If you're not raising your hand, I will try to visit you during work time to make sure that you're okay. All right. So that's the old stuff. Let's talk the new stuff now. Everybody find the notes for today. I'm going to pause for a second while you pull up the notes for today. You're looking for today's date, which is the 27th. How many chances? By the end of the hour, I want to make sure you understand how to do this, another technique to factor polynomials. Basically, it's called synthetic division. All right. So, long division we already practiced, so I don't think we need to do another one of those. Synthetic looks like the thing on the right side of the green dotted line. And here's how you make it work. You use the root. Now, first of all, if this is a factor, that means like x minus 3. What would solve that would be a 3. Do you get how the 3 would make that x minus 3 equals 0? There's two things. This is a factor, the x minus 3. That's a factor. What's the root for that then? Must not explain this well enough. It's the thing that makes that equal 0. So what's the root for it? 3. Okay. So it's one of those two. Well, in synthetic, we make it quicker by getting rid of the x. So we just use the It's not a minus 3. We used the positive 3. The thing that would make this equal 0. So 3. All right, so I put a 3 right there. Next, stripping out all the variables makes this go faster. So I'm going to have a 2. What do you think I'm going to put for that? A negative 1 and a negative 15. A 2, a negative 1, and a negative 15. All right. Now, this is a little bit challenging to start, but once you get used to like how to do this, the synthetic division thing goes really fast. So you take this number and you drop it down, straight down. Okay, so that 2 goes down there. Then I'm going to go 2 times the 3 makes 6, and that 6 goes here. And now take a guess what I'm going to do with the negative 1 and the 6. Right? And I'm going to get 5. It's basically adding those two numbers. Then take a guess what I'm going to do with the 5. Not times 2 is a good guess. Times the 3. 5 times the 3 again. And that makes 15. Ooh, look at that. And notice, of course, if it's a 15, it's really a positive 15, right? What happens when I add 15 plus 15? I get 0. And if I get a 0 at the end, it's the exact same thing as if I got the 0 at the end of a long division. And at the 0 at the end of the long division would mean I had done it perfectly and I was done. So what is the answer? Pay attention close now. The answer is this right here tells me that it's x minus 3 times this part right here. That tells me that it's 2x plus 5. Final answer, x minus 3 and 2x plus 5. It factored. All right, it's called synthetic. Let's see if you can handle synthetic on this one. Everybody turn to the yellow slide and turn it my way to make sure I know you're in the right spot. Excellent, thank you. Okay, there's one person I'm still going to go check on in a minute, but this negative 8 here is x equals negative 8. Notice that's not written like this. So I can use the negative 8. If it had been written like this, I would also use a negative 8. All right? So the solution is supposed to be negative 8, so I put that right here. Then I strip out the variables to make it go faster, and this will be a 2 and a 10 and a negative 46. Start the process by dropping the 2. Now see if you can finish it. Remember what I did again? It was multiply, then add, then multiply, then add, then multiply, then add, and then when you're all done, if you have a 0 at the end, it worked, and you should be able to interpret your answer. Did it work or not? Ooh, interesting. So maybe you're both wrong. Well, I don't know. I'm going to find out. 8 times negative 2, negative 16. Would you agree with that so far? Yeah. Add those together, and what do you get? It's positive 6 or negative 6? Negative 6 times negative 8 makes what? Ooh. All right. And then there's 2 left. That's the remainder. Bottom line, did it work? No. Is negative 8 a solution? No. Could I write something intelligent, though? Yes. Watch. X plus 8 times 2x minus 6 plus 2. Very good. Now, it's still, though, the answer to the question is, no, it's not a solution because we had to use that remainder thing. But if you multiplied all this out and added that 2 at the end, you'd get that. Okay. Let's try another one. Go to the, what color is that? I don't know. Pinkish? Sort of like a dirty pig color? All right. Okay. Kind of a little view into his subconscious mind, which is scary, I guess. All right. So we start with a 2 there. Now see if you can do it without any more help from me. I'm going to pause for a second. There's no missing terms, I'll note, because in a moment there will be, and you'll have to remember to put in a 0 to hold the place. But there's no missing terms here, so. All Okay, so we're back, and we dropped that 3 down. 3 times 2 makes 6. 4. Okay, hold up just a second. Okay, so where's the mistake? I'm missing the mistake. Oh, thank you. This is a -2. Okay, I started the whole problem now. Okay, so you still drop that, and then 2 times the, okay, so that's -6. Now it makes sense to me. Now I add them together, -2. Now I multiply them, +4. Now I add them, +1. Now I multiply them, -2. Now I add them down, and that makes -1. And now I wait for the very last number for that little box at the end. -1 times -2 makes +2. Does it work? Yes, because there's no remainder. But then can you interpret your answer? Because otherwise it's just a bunch of numbers on a page. So what it is this factored to what? Raise your hand if you got it factored. You understand how to interpret it. Several of you. All right, not all though. Watch. This part right here makes a little parenthesis of x plus 2 because the -2 would solve this. All right, then this becomes, got to be careful here. I actually kind of like to do it this way. I'm going to move the x plus 2 right in front of this, and then I don't have to rewrite because I'm a naturally lazy person. I don't want to have to rewrite all of that, so I'm just going to put it like this. Now, the x goes right here. The x squared goes right here, and the x cubed goes right there. The first number is just a constant. The second number is an x, the third number is an x squared, and the fourth number is an x cubed. All right, now the only thing this is missing is a little plus right there. So now I've got it. There's my factor. It's factored. But do you remember that on the factoring quiz, so many people got them wrong because they didn't factor it all the way? Yes, these are actually that hard. Now you have to take this part and see if that will factor. What? Okay, but no, that's too cruel for the second day of learning this. So, but you're going to have to do that tomorrow. All right, so just watch out for that. Oh, that's right. Okay, fine. On Monday or whenever that is. Okay. So, with a missing term, do you get that that one should have an x to the 4th in it, but it doesn't? So what do you put for that? A 0. And normally you'd have 0x. Okay, we got to work on this. I am recording right now. Already recording. So when you've got the this with a missing term, you've got to put the 0. And remember, this is now this time we didn't even put a little box here and a little line here. You have to do all that yourself. Okay, so see if you can do it from scratch with a missing term. The missing term is just a 0. Because remember, we don't copy any variables over. It makes it faster. Okay, go for it. And Mr. T remembers how to start now. That's good. Snoop actually taught you something important. All right, I'm behind you, but I will try to catch up now. So it's 3, and then I do a 1, and then I have that missing term, so I put a 0. And then I put -11, 5, 8, and -15. At the end, I'm hoping the number I put in the box here ends up being a 0, because then that means it worked. Okay, drop it like it's hot. 1, 2, 3 is 3. Add them, multiply them. Add them, multiply them. Add them, multiply them. Add them, multiply them. Yay, it worked. So final answer. I drop this part down and make it x minus 3. I take that whole part and now I slap in some x's and x squareds and stuff. That's the x. X squared, x cubed, x to the 4th. And then I'm going to put a plus there to make this make sense and a plus right there to make that make sense. And now, do I really need a 1x to the 4th? No, I could clean that up by just making it a plain x to the 4th. It's not wrong if you have a 1 there. It's just more messy than it has to be. Same with this one, negative 1x. This kind of looks dumb. Just call it an x. All right, and then, is it possible that this part right here could factor again? Yes, but it'd be such a pain in the butt that we aren't going to make you do that yet. You haven't learned how to tell what number might work. We've always been telling you, does 3 work? Well, there's a way to know what number might work in this, but we're not going to tell you that yet. You're not ready for that yet. All right, so bottom line, was 3 a solution? Yes, and it's because there was no remainder at the end. We were able to factor it. Your answer that's much more powerful than is 3 a factor is what does it factor to, and this is what it factors to. Okay, I don't think we need to do much more practice. This one's a little weird because it not only has 1 missing term, it has 2 missing terms. But do you get how they just put in 2 zeros then? It's not that hard. It's pretty much the same thing. All right, so let's give you more time to work on homework today. So your homework is the factoring using synthetic division. And the assignment would be listed under today's date, which is 2-27. And do you have a question before I end the video, or are you?
Yeah.
Okay.
When you put it into the equation, if it's negative, does it stay negative, or does it go positive? Is it like the opposite?
When you put, you mean this number here? Or what are you talking about?
No.
When I put what number in? These numbers?
-6, does that go to the opposite, or does it stay negative? Or I mean, well, like numbers that you put into the equation.
The numbers I put into the equation. What am I putting into the equation? You mean these numbers?
Into the factor form.
These guys. That thing?
Yeah.
These numbers. Those stay the same as what they are.
Okay, so they don't go to the opposite.
No. I only am putting in pluses because if you have a negative there, you've already got something to kind of keep the terms separate. But like I didn't have a plus right there because that was just a 5. So I just made it a plus 5. So all I was doing is putting in plus there, and I think this one also was the one that needed a plus. The ones that have a minus already have something in between to kind of divide the terms up. Okay. So that's all I got for you for the recording for today. That was synthetic division.